things like this, similar like virtual machine concept. Okay, so those are from IBM. It's even used still until today. So in the later time, 1999, you will see that okay, VMware first started the x86 based platform virtualization layer. Okay. So all the computer that we are using currently, especially Intel and AMD, we are all using the x86 based platform. Okay. So nowadays you will see that from the processor perspective, okay, we have the RISC processor. Okay. So just some extra information on CPU platform. So first will be x86, okay, like you will see from Intel or even AMD. Okay. So second one will be RISC or maybe Spark, okay, server. This is also used in IBM and things like this, okay, even Solaris. Third one will be ARM processor, okay, that is used in mobile CPU, okay, which is getting more and more popular now. Even Huawei do come with their own Huawei Kunpeng processor. Okay, it's an ARM-based chip, okay, homemade from Huawei themselves. It is also used in the storage system and the server platform. Okay, so later on, they might also develop the fusion compute to run on their ARM processor. Okay. So these are the few processor platform. So earlier, IBM is actually looking into their own RISC and Spark server level for virtualization. Then VMware actually targeted x86 is the more popular and more affordable platform. Until now, you will see that in the greater market nowadays, up to like 80% of the customer is using x86 platform, which is far more cheaper and affordable as compared to mainframe. So VMware started the idea, why not create virtualization product based on x86 platform that actually makes them pretty successful until today. So you see that the first one started as early as 1999. So you will see that in the market, VMware is already there for 20 years. Okay? So the latest version for this year, it will be version 7. Okay. So now the popular one is 6.7 for VMware, for example. Okay, so later on, Zen actually officially open source. Okay. So when you talk about the virtualization platform, as you can see here, VMware has its own project and product, okay, that achieve the similar objective. Zen is another platform, okay, that is supported in Unix or Linux platform. So Zen is open source, whereby everybody can actually utilize this as a feature module in their own operating system, okay, that can be shared and co-developed together. And also later on in 2006, KVM is also announced. Okay, so now why they actually touch on this too? This is some history lesson from Huawei. Okay, so when you talk about Huawei Fusion Compute solution, now if you have anything with 6.1 and below, we are using Zen platform. Okay. Zen virtualization platform. 6.1 and below. So they all started off with the Zen virtualization platform for Huawei solution. Okay. So later when they actually change, okay, where we have currently here, from 6.3 and above, they move to KVM virtualization platform. Okay, so from your material, documentation, and even your exam question, they will still cover some information regarding Zen virtualization platform. And in this topic, we will talk about how Zen differs to KVM also. Okay? So there are no best platform. Is the way how they actually achieve the similar objective. Okay? So if you are talking about, supportability and openness, definitely KVM is more common in the open source world currently. So a lot of vendors are looking into KVM virtualization platform that where actually Huawei also look into it. So if you are looking into OpenStack solution compatibility, OpenStack is compatible with KVM more than Zen, especially. Okay. So these are some of the versioning that you will see. So when you're talking about 6.3 and above, like 6.5 that we are currently discussing, we are using KVM. Earlier one is all based on Zen. Okay. So later, HP also announced that there are HP Unix, HP UX platform to support integrity VM. And 2010, Red Hat actually supported KVM as their virtualization platform. So when you talk about KVM, there are a few vendors supported. Red Hat actually have their own KVM platform as a selling product, and Huawei also using KVM for that basically. Okay, because it's a open source platform, they actually utilize the code and closed source develop with enhancement and things like this, and provide you the support. So if you are keen on that, open source does not come with any support. It will be supported by the communities of engineers like you guys also. If you have any issue, you can only look for help from the forum that you might not even get any sometimes, okay? Because it's a joint open source project. So for enterprise environment, most of the time, they still prefer closed source, okay? So that the vendor can provide support when they have issue. Okay, so you see that over here, the time frame is a bit off, maybe. So on the Microsoft here is actually 2010. Okay, so in the Red Hat, it's actually 2008, just for you to do some adjustment. So Linux container is actually announced in 2008. This is where we have the operating system virtualization platform. Okay. So using Linux as the base OS, we can create multiple different container instances that can share the same operating system to deploy different application services, for example. Okay. So each of the container will hold its own registry, application, network connection, etc. Okay, so we further virtualize not only the hardware and also the operating system. So using the container base, we can save a lot of capacity and OS deployment time because they are sharing the same base OS. Okay, so we are looking onto virtualizing the OS level. So in later time, 2010, Microsoft actually introduced Hyper-V virtualization platform into their Windows Server 2008 R2. It has their test platform. So this is where they all started. Okay, until now, Windows Server 2019, they still have Hyper-V in it. So some of you may be familiar with Hyper-V solution. They are providing as a free solution for 2 instances to run, for example, and you need to pay extra license if you want to run more VM instances in it. Okay, so this is on the Hyper-V Microsoft. So later in 2011, IBM, Red Hat, HP, all of them actually formed the Open Virtualization Alliance to accelerate KVM adoption. So you will see that KVM is a more preferred solution, especially for public cloud solution. So you will see that from Huawei, Huawei Cloud is using KVM. Amazon AWS, is not mistaken, they're using VMware and also Zen. Okay, so for other cloud, for example, like Google, everything, maybe they are using KVM. Only Microsoft Azure has their own platform. They're using Hyper-V backend, for example. Okay. So Docker is another extra software module plugin, mainly designed to simplify and also manage the container solution similar to Rocket. So we are now in another phrase for virtualization. Hardware virtualization is still in the market, which is the base for that. And we can now further virtualize the operating system with container base. Okay. So you will see that even Microsoft solution on their Windows platform, they can also do container-based virtualization if you want to test it now. Okay. So now, as a comparison for your physical machine and your VM, so you will see here, this part is basically your physical server. Okay, so this is basically physical server instance. Okay, I do not introduce any operating system or software on the physical hardware itself. So I just install the host OS straight away to the machine and run one application to it. So you will see that over here, the physical server actually tells you it's considered as one instance. And then when you're looking onto virtual machine level, how does it differ? It will still run, over here is the application instance that we talked about earlier. So you will have the guest OS plus application running on the virtual disk. And your XML file is basically your guest machine configuration. And all of these will able to run on one physical hardware, which is shared resource pool now. So in order to provide this particular functionality, your host machine will need to install what we call the virtualization layer. Okay. So now for the virtualization layer, they come with a lot of different names. So initially you will see here, they call it the virtual machine monitor. Okay. Virtual machine monitor. So this is what we call the virtualization layer. Okay. So this is the virtual machine monitor, they call it VMM. Second one, you also see some name called hypervisor, which is used in VMware and also Microsoft. Another one will be universal virtualization platform. Okay, so this one is called UVP. So these are the few names that they use to refer the virtualization layer. So you will see that all these are different naming. They are trying to achieve the same objective, mainly to virtualize your hardware resources. Okay? So you will see that some vendor prefer to use the word hypervisor like VMware and Hyper-V. Like KVM and Zen, they like to utilize UVP or sometimes VMM. So when you see these three terminology, it's referring to the virtualization layer. Okay, so this is generally your particular OS layer considered that will install to your machine here, as you can see. So your physical machine will require to push in the software, okay, the VMM. So what is this VMM actually referring to? Yesterday we covered a bit on the installation. This is basically your CNA, okay, your CNA software. So CNA software is a VMM, hypervisor, or UVP layer. After you deploy it, okay, do some basic configuration, and later we can create guest machine to run on it. Okay, so these are the few layers, as you can see. So they always refer virtual machine, okay, as a guest machine, whereby over here, this is a hotel and guest relationship. Okay, so in the virtualization feature set, your VM can sit on one host as a guest. They can even move and also run on the other host within the same cluster as a guest machine. So over here, when you're looking onto the documentation, when they say host machine is referring to the hardware, guest machine is referring to the VM running on it, and this guest machine will host its own guest operating system. Okay, so these are the terminology used. So the operating system will then later hold your application. So you can consider this as one machine individually, and you can run multiples of these guest machine in one single host or in a groups of cluster hosts if you want to. Okay, so these are the comparison. So you will see in the types of compute virtualization okay, or hypervisor. So in the market, which is quite popular, they have the bare metal virtualization and also hosted. And sometimes they call the type 1 is the bare metal virtualization. Okay. And also type 2 is the hosted virtualization. So what is the differences here? So you will see here for the type 1 bare metal virtualization, your hardware will run the VMM straight away. Okay, VMM straight away. So you will see that over here, your VMM will also act as your operating system to mainly control and run your hardware itself. Then later create VM or guest machine to run on the VMM layer straight away. So these are the two types of virtualization in the market. There is no best solution. It's just how they actually achieve the similar objective with different architecture. So when you look into bare metal virtualization, you will see that VMware and Hyper-V is using it. Hosted virtualization, here as you can see, we are using it in KVM, okay, that we are focusing as a platform later. So how it differs? Running hosted virtualization, you see that from a diagram, we have the hardware layer. Now we need to actually install the host OS first. Okay, so this is the Linux operating system, and then the VMM here will be an added module. Okay, added module. So you will see that this hosted virtualization with the Linux OS, I can even run application directly on the platform like a normal host OS server. But most of the time, if you want to achieve a stable platform, we don't run the application anymore. This particular host is solely serving the KVM layer. So that running this extra KVM layer on the Linux machine, I can now create guest machine to run on it. Okay, so these are the differences. With hosted virtualization, I will require a Linux OS at least before I enable the KVM solution. Okay, then let's look into the Huawei Fusion Compute solution. So when you go for Huawei Fusion Compute solution, so initially they will have what they call the Euler OS. Euler OS. So this is actually a Huawei enhanced Linux. Okay. So your particular Fusion Compute CNA, when you install the ISO, right? The ISO actually will help you to install the Euler OS. Okay. It's actually a Linux enhanced by Huawei. So they repackage it and call it Euler OS from Huawei. So when you look into the documentation and things like this, when you see Euler OS, it's basically Huawei flavors of Linux. Okay, Linux. So they repackage it with their own brand name, things like this. And later, after the Euler OS is deployed, they will enable KVM module, okay, on the Euler operating system. So when you are doing the CNA ISO installation, they are basically deploying the OS plus enabling the KVM module to make the hardware server ready for virtualization platform. Okay, so these are some keywords, especially when you look into the documentation, you have better idea what they are referring to. Okay. So these are the differences between bare metal and hosted virtualization. So KVM is using hosted, bare metal virtualization will be VMware, Hyper-V, and even Zen platform. So last time for Huawei, okay, they are using, this one is also used by Zen. This one is used by KVM platform. So if you go for Fusion Compute 6.1 and below, they are using something like this. Okay. So 6.3 and above, they are going for KVM. That's why don't be surprised, you will still see Zen information around. Okay, this is how it is as a history. Huawei still have Zen solution because they are still having some current customer that are using it. Okay, so they will not drop it 100% still. They will still in support, for example. But for newer deployment, they will be running 6.3 and above. It will be KVM based. This one is not really a good or bad between these two types of platform. It's just how they actually works backend. But the initial objective here is both platforms are able to now create multiple VM to run on the same hardware. Okay, so this is the final message. Okay, so as a virtual machine, what is the characteristic using virtualization layer? So you will see that your hardware here will be partitioned. Okay, in the resource pool, they will further partition it into smaller pools of resources. So here maybe they have like 16 cores of CPU, then they have like maybe 128 gigs of RAM memory, things like this. So this guy will be having maybe 4 vCPU. This guy may be having 2 vCPU, and then this guy 2 vCPU again. So I will basically partition them into multiple shareable resources to use by the virtual machine. So this guy may be 4 gigs of RAM memory. This guy may be 2 gigabyte. This guy may be 4 gigabyte again. So later on, we'll show you how they actually share these resources on the single physical hardware. So with the higher resources count, we can now create multiple VM to share these resources. Okay. So we partition to multiple different VM to be used. And all these gas machines, you can see here. So the gas machine will be running its independent operating system separately. Okay. They are isolated by nature. Okay, isolated by nature. Although all the virtual machine running on the same server hardware and share the same host OS, okay, because they're running on KVM, but inside the gas operating system, if you have any issue on this VM gas OS, it will not affect other virtual machine gas OS actually. So over here, we are able to provide 3 different instances, and if one is down, you still have the other 2 as a backup if you are running on a cluster application basis. So this is by default isolated. They can only communicate with each other if you allow them to communicate from the network perspective. Okay. Other than that, they have no communication between them from the hardware or even software level. Okay. So the only way is through network connection. Okay, so encapsulated, as you can see here. This one earlier slide we already discussed. From a physical machine, we now convert it to a virtual machine. So the virtual machine will be encapsulated into a folder. Okay, each folder will consider to refer as one individual VM. So within the folder, you will have your configuration file and your virtual disk data. And by data store nature, all the VM is actually encapsulated in folder and also isolated from each other. Okay, so most of the time your data will not sit in other virtual machine folder if you do not want them to. And another characteristic will be independent. Now your machine is a virtual machine. So being a virtual machine is basically an application instance. So this application instance can roam freely in the same virtualization platform, if you have a clusters of nodes that we actually showed you yesterday as a simulation installation, the VM can run from one host to another freely, even when they are online. Okay, so we can provide seamless live migration from one host to another, okay, with some infrastructure dependency. So if your infrastructure is ready, your VM can actually migrate anytime without shutting them down. So these are the benefits of virtualization, where your physical machine cannot really do so earlier. Okay? So these are a few characteristics of your virtualization. So next thing, we discuss a bit further on the CPU virtualization, okay, which is just an introduction. So you will see here, full virtualization and para virtualization, the only difference here is your hypervisor that talks to the gas OS itself. They are using different driver set, okay, different driver set. So over here, you see both of the environment, they are trying to achieve the same objective. Okay, the application would like to utilize the hardware resources. Okay, so your end result will always be going through the hardware still. So before they can access the hardware resources, they will need to go through the gas OS in your VM. Then the gas OS will need to contact the hypervisor with the respective driver. For example, if you would like to utilize CPU, they will have a different driver for them to queue up your particular resources. Okay. So similar to para virtualization, your gas OS will have a para virtualized driver to contact the hypervisor. So the hypervisor will now start to queue up your gas OS operation and then further to process it with the hardware. Okay. So initially your hypervisor might come with multiple VM. So when you put it this way, it will be easier for you to understand VM1, then VM2, then VM3. So they will take turns to process onto the CPU. Maybe this one process first, this one process second, this one process third. So they are queuing up the CPU usage operation on the hypervisor layer. So all this queuing happens in maybe millisecond or nanosecond level, which you do not really feel the delay. That's why you see that how can all these application or gas machine can share only one or two sockets of processor. It is the magic that has been done by the hypervisor. They actually queue up all these operations and then further let you to use it in sequence. Things like this. So the hardware CPU, they don't even know what they are actually processing. They will thought that all these operations come from one same machine, but it's actually not. Okay, so this is the idea of CPU virtualization. That's why you see that one hardware you can process multiple different tasks comes from different virtual machine itself. That's why if your hardware is powerful enough, this delay will not be very significant. Okay, but all this hardware will always have a limitation. For example, you buy an entry model CPU from Intel Xeon, for example, you go and run like 100 virtual machine in it. It's like a banking industry. So when you have a bank counter that only served by one people, and then you go and queue up like 100 people over there, sure thing everything will go and slow down. Things like this. So over here, you still have limitation. If you're running lesser numbers of VM on the same hardware, generally you do not have any delay from it. Okay. So when you introduce more and more VM to run on the same hardware, which is very heavy loaded, then all your VM will start to slow down at the same time if you do not do any QS or control to it. Okay, get the idea? So the full virtualization and para virtualization is more towards the driver and communication between the hypervisor and the gas OS layer. That's why you don't see much difference between these two. Okay, so the end objective will be processing your application requests via the hardware itself. So the hardware can process the result to the user or send over to the other side, for example. Okay, so this is the CPU virtualization technology. So if you need more white paper, you can always Google what CPU virtualization is that. They will give you a lot of extra information on it. Okay, so those are for CPU virtualization. So next thing will be memory virtualization. So how can they virtualize your server hardware memory? So you will see here from a server hardware memory. Okay. So here I have a pretty huge RAM memory capacity, maybe 256 gigabytes of RAM. Okay. Then you see that here the RAM memory will be segmented into smaller space, and all this space is actually shared by the VM. So this VM may be running on 4 gig RAM memory. Okay, VRAM for example. This guy running on 2 gig. This guy may be 3 gig. This guy may be 6 gig, for example. Now all this space will be sharing the physical hardware here. So this is on the physical RAM space. Okay. So your RAM space by default will not have any reserve to any VM. Okay, but you can change that configuration if you want to. So by default, your RAM memory will be free for all. Okay, free for all. Meaning to say, your RAM memory usage will be based on first come, first serve basis. That's why I will have a huge amount of RAM memory. I will assign based on the request by the virtual machine. So you will see that over here, your space usage is actually color coded to refer that this RAM memory is actually shared by multiple VM at the same time. Okay, so this is one of the options for your memory virtualization to be sharing the same hardware. So if your OS is holding a lot of RAM, the space will still occupy there always. That's why most of the time when we are talking about virtualization platform, RAM memory is the resource that always run out of it. Okay? So we always run out of RAM resources to assign to a different virtual machine, because nowadays if you are running Windows VM, okay, Windows operating system generally will hold up a lot more RAM memory as required. CPU itself, it will based on the load. Okay, if you have any loading only, they will utilize it. But RAM memory, a lot of time, application holds the RAM for quite a long time. So if they release the RAM from the virtual machine guest OS, the space on the physical machine will also get released. Okay, that is why the RAM part will be pretty higher as compared to CPU when you purchase a server always for virtualization platform. Okay, so next thing will be the I/O virtualization. Okay, so like I mentioned just now, if you are going for full virtualization, they are using emulation to help you queue your particular request on the hardware itself. For I/O virtualization, this is looking onto peripheral, like other hardware, similar like keyboard, mouse, USB, GPU, whatsoever things like this. Our virtualization will be using something similar they call front end and back end driver, both actually handled by the hypervisor. So they can further virtualize this peripheral, like in one server hardware, the USB can be passed through to different virtual machine via this I/O virtualization. So you can generally share the port, okay, and also pass through them to the virtual machine itself, that you can now connect pen drive for them to copy data if you want to. This is one of the examples. Okay, so if you are going for Zen machine, okay, Zen platform will require to create a domain 0 virtual machine. The domain 0 will actually do all these hardware pass through and also queuing access. Okay, for etc. I/O peripheral. So these are the few different types of them. Okay, so next thing will be cloud computing and virtualization. How does it differ? So once you have the virtualization layer ready, I can utilize this platform to create multiple numbers of VM. So if you have 100 physical machine cluster farm, I can generally create up to like 10,000 virtual machine, and this 10,000 virtual machine will be served by the cloud computing platform, as you can see here. So the cloud computing will be serving all these resources as a service that I already showed yesterday from Huawei Cloud. So most of the things will be running on the hardware platform backend using virtualization layer. Okay, so to be exact here, you will see from the virtualization layer. Okay. So I can provide from here virtual machine. Okay, for maybe ECS compute server. I can also create a VM for maybe AI application. Okay. So I can even create extra things like maybe Linux for container-based sharing. Okay, application. So all this made possible with the virtualization layer backend. Okay, so it is matter how you can orchestrate it. Okay, so from Huawei, this cloud computing will be using OpenStack solution plus managed one. Okay, so the OpenStack will talk to the virtualization layer to create the resources. Okay. Management will be basically your service portal. Okay, so the user will access via management, okay, to create all these resources as a service and manage on their own. Backend will be using OpenStack to orchestrate and create the resources using the virtualization layer in your data center. Okay, so this is the relationship between cloud computing and virtualization. Okay, so pretty easy. Okay, so over here you will see mainstream virtualization technology. So we have the okay, open source and the closed source solution. So open source, as we already discussed just now, it will be Zen and KVM. Closed source, it will be vendor-based, Microsoft Hyper-V, VMware ESXi, and also Huawei Fusion Sphere. So when you are going for closed source solution, you need to pay license fee to all these vendors, and in turn, you can also subscribe to their support contract. If you have any issue, they can always support you for the product solution. Okay, so these are the few different types of them. So next thing will be the differences between Zen and KVM. Okay, Zen and KVM. So we'll see from the platform here how Zen actually looks like. Okay, Zen will have your hardware, then deploy the Zen virtualization layer. So this is type 1 solution. So after they deploy Zen layer, they will have a domain 0 virtual machine. This is the first virtual machine that they will deploy to handle your backend driver. Okay, handle your backend driver for the domain U is basically your virtual machine. Okay, so let me write down here. So your domain U is actually your VM instance. Okay, so this is the first, they call it sometimes management VM. So this guy will in charge of your I/O virtualization. Okay, so Zen over here will in charge for your CPU and RAM memory virtualization. Okay. So your queue for your CPU and RAM memory, they'll go to Zen directly. For other peripheral like maybe network, they will go through the domain 0. Okay, so this is the idea of Zen platform. So if you are going for Linux, okay, pretty similar. Linux over here will be using type 2. Type 2, we require a Linux host OS to be ready before I enable the KVM module. Okay, before I enable the KVM software module. So the KVM software module will be the one that virtualize the hardware as a resource pool. And your guest OS will have a QMU, similar like a driver, for the guest operating system to communicate with the KVM. So any request that goes through the hardware resources usage, they will actually queue up from the QMU driver to the KVM the KVM will help you to queue them up before they actually pass it to the hardware for processing, for example. Okay. So these are the differences between your Zen and Linux KVM platform over here. So if you compare Zen deployment, this domain 0 will require some extra resources because it's a virtual machine here. So this one will require 4 vCPU, and if I'm mistaken, around 8 gigabytes of RAM memory, okay, for this guy. So it will have higher overheads if you compare to KVM. So over here, you will have some overheads of CPU and also RAM memory, but you don't generally isolate it or partition it. So in Linux and KVM, they will increase the overheads as you import more virtual machine into it, like VMware, for example. Okay, pretty similar. So last time when you configure Zen solution for Huawei, you need to also decide how much resources for domain 0 to put in. You need to increase the specification for the domain 0 to increase the performance, okay? Because they are doing a lot of I/O peripheral connection to the VM. If this domain 0 is slowing down, your virtual machine connection will also slow down at the same time. So the domain 0 needs to scale according to your infrastructure sizing. As for KVM, they will scale automatically with the overheads that is running on the KVM module, okay, sitting on the Linux operating system. Okay, so these are the differences between the KVM and Zen platform. Okay, so next thing we move on to the KVM solution. So what is a KVM? KVM full name stands for Kernel Virtual Machine. So this is a native Linux function. So most of the Linux distribution do support KVM module. Okay, you just need to download or enable the KVM module to run. So most of the Linux operating system can actually act as a virtualization hypervisor. So this is a native software module. Okay. So you can download any Linux distribution like CentOS, Ubuntu, whatsoever that enable your own KVM. It is also supported. Okay. So in Huawei, they actually package it to EULA OS with KVM. Then you can run your virtual machine with the QEMU. So this is the driver, okay, that they are also used for your CPU and RAM memory queuing whatsoever, things like this, which is natively been supported in KVM. Then later you can run your guest OS on it as a guest machine. Then each of them will have its own registry and binary and also application. Okay, so over here we will have the extra things to talk about, like the management part. So in your okay, virtual machine, you will see here, this is basically your okay, this is basically your physical server, okay, or you can also call it the CNA, for example, if you want to relate it. So all these are your virtual machine. Now, each and every one of your CNA node, they come with a Linux OS and the KVM module only to run your virtual machine, but they don't natively come with a management interface. So this is mainly used for management. So you will see that the management tool here will basically referring to a tool similar to your VRM virtual machine that will provide you the web GUI for cluster management. Okay, so they require extra software set. So as you can see here, the lib virtual, okay, this lib virtual is an open source tool mainly designed to manage KVM node. So the VRM will come with multiple different management tool, okay, to facilitate runs with the lib virtual to manage multiple KVM node in one cluster. Okay, so these are some of the tools that they actually get from open source, put it into their software, and then to manage the cluster itself. Okay, just to let you know all this. So from Huawei perspective, they repackage it to CNA node for KVM, and then VRM is mainly targeting on the management part. Okay, so we have more idea here what the product actually referring to. That is why in Huawei, if you deploy only the CNA node, there is no way for you to do clustering whatsoever and things like this natively from the host itself. You will need to deploy the VRM node for easy KVM node management. Okay, so this is the idea. So you will see here for your lead virtual. Okay, so if you go for normal KVM host, okay, you need to do command, things like this to manage your single KVM host. So this is on single host. Okay. So you will see that over here from your particular virtual library. Okay. So this lead virtual can mainly manage multiple CNA nodes in one particular cluster, for example, using the lead virtual. So this guy will be a standalone CNA, for example, that you can't do much with it. Okay, or KVM. So you have a lot of feature for virtualization. It's best to apply with a cluster technology together. Okay, so the lead virtual has a management tool. We're able to help you to do all these things as an added feature that does not come with the KVM natively by default. Okay. Okay, so next thing you will see that we have different driver set. Okay, so over here, if you are using KVM native QMU driver, so what they will do here is initially when the guest OS would like to access to the server hardware equipment, so they will go through the KVM module first. You see first from the OS, then the device driver QMU in the guest machine. So they will contact the KVM module. Then the KVM module will update into the IO share page and then to the QMU IO emulator code. So this is the actual driver in your Linux operating system before they will pass to the server hardware to process. Okay. And they will still get notification of that to reply the particular response to the guest OS. So over here, it will work as a virtualization technology, but in turns, you will need to go through a lot of different component and module that might actually delay your performance. So the performance here, we're looking onto latency. That's why in KVM, they have another special driver they call the virtual IO. So if you are using virtual IO, they simplify a lot of things over here. Okay, so they will contact using the front end driver, then to the vRing and direct to the QMU emulator driver with virtual backend driver, then to the device straight away. So the KVM here is just mainly to monitor and get notification for all these tasks. So you will see that comparison to the earlier one, your generally process will be much more leaner and faster, okay, using virtual IO. So in Huawei Fusion Compute, virtual IO driver set for your disk, everything is preferred. Okay, so later we'll talk about it more later when you need to install the tool whatsoever. Okay. So those are for the KVM introduction. So lastly, a few more things. We'll discuss about the Fusion Compute feature and solution. So when you talk about Fusion Compute, we have the VRM. This is to manage the entire infrastructure, okay, entire infrastructure. So over here, you will require still physical hardware. You will need the CNA node here. Okay, CNA node. So I install CNA software onto it first. Then I will require the storage system. Okay, so this one will be used for your data store, for example. So later tomorrow, we'll also discuss about the storage topic, then you have more idea on it. So all these cluster farm will be sharing enterprise centralized storage to store their virtual machine data. Okay, so your virtual machine VHD will be stored here in this layer. So on the CNA node, I'll be using CPU and also RAM memory plus network card. Okay, So this is referring to your storage network initially. Okay. So as a cluster over here, we can have like 4 nodes and then 3 storage systems to be shared. So we can now create multiple virtual machines to run on different CNA nodes in this particular virtual cluster. It's all managed by the VRM software. So later I will deploy into the physical hardware to let you see how the process actually goes. So you have more idea when you plan to deploy in your own environment later on. Okay, so next thing will be the Fusion Compute advantages. Okay, with the VRM, I can create virtual resources, manage physical resources. Okay, things like this. So physical resources will be referring to your CNA node, your storage data store. Okay, looking into your local disk or a centralized storage system. Then physical resources also refers to your network port equipment. Okay, that you can configure which port to use for which VLAN tagging that we'll discuss further later in the network topic. So using all these physical resources, we can now create our virtual machine to run on it. Okay. And with this CNA plus VRM Fusion Compute solution, we can now do quick virtual machine provisioning. So with virtual machine provisioning, we can create multiple VM using cloning technology, deployment technology whatsoever. We will actually faster in VM deployment. Okay, so lastly, these are the functionality and role provided by CNA. So you see that CNA actually provide the hardware resources to run your VM. Okay, so this is your KVM layer only. The VRM is the main software backend to provide you all the extra feature like maybe virtual network, then your virtual machine lifecycle management, delete, create, power on off, all these things, adjusting it whatsoever. You can also provide cluster feature like migrating your VM from one node to another and provide the web UI portal for you to access the infrastructure to manage it. That's why the VRM machine is also pretty important. That is best recommended to deploy active standby mode. Okay, to VRM to support this particular role, active standby. Okay, so that's about it for this topic to understand in compute virtualization. Okay, so we will stop for a short break. If you have any question, you can post to the group. So we will stop for a short break and continue later with the lab demo. Okay, so like I mentioned, if you are new, join today, please remember to message Xinjiang to add you to the group. And this is the Google Sheet link if you want to access to further information and things like this. So we will stop for a short break. 15 minutes for the go. So I will start again Malaysia time. 9:30. So you can see from my on-screen clock. Okay.
Daniel. Hello, Mr. Daniel.
Yes.
Is it possible to get a PowerPoint slides you're using for this training? Because there are no comments on the slides, and most of the slides just have images, and then you do most of the explanation of the images. So if there were comments, like some of the Huawei and PowerPoint slides that we made use of, it will be easy for us to read up and gain more understanding on our own.
Yes, okay. Now the PPT slide, okay, is only available for trainers, and you guys will be a trainer later, right? So you guys as an ICT Academy do have this permission, but you need to get the correct administrator to assign you the permission. So you see here from my Google Sheet, there's a link called Training Material Download Portal. You can get all your resources here from this link. So when you click on it, it will bring you to the Talent website where you can download PDF copy as a trainee zone. you can also download trainer copies PPT here. But they will require you to log in with your ICT Academy account, which
Yeah, but
determine whether you have.
in
Yeah,
this option here, I don't think the PPT documents are available. Can you just confirm to us so that we can at least have a view?
you see here when I actually fine tune to cloud computing and HCIA under trainer zone, you are able to download for instructor. This is actually your PPT, but it will require you to have certain permission before you can download it.
Okay.
Okay, so the permission is not by me, it's by a respective country person in charge for the ICT Academy part. Okay, so if they already assign administrator to your university, then you need to look for the administrator account holder in your university to assign you this permission if you cannot download. Okay, I'm just here to point you where to look for it, but you need to get the permission by yourself. I cannot do that for you.
You get the instructor. Okay, instructor. No problem. Thanks for the information. I appreciate it.
Okay, welcome. So it's in the Google Sheet. So the link is still there. So you can copy it down, bookmark it somewhere, then you can access it later. Yeah.
Hi, Daniel.
Yes.
Sorry, I came late today because I received a message that said that the lesson will begin at 5 today for us in Mozambique. I would like to ask you, if possible, to give me or to do a resume in these 15 minutes. Is it possible?
I think the Huawei person in charge in the group, they are looking for ways to share the video to you guys. Okay, so if the video is ready, you guys were able to access for revision purpose. Okay, it's already discussed in the WhatsApp group, so you wait for them to update you because this is considered Huawei property. I'm just a trainer to present. I have no authority to do all this sharing. Okay, so you need to wait for the Huawei guys to prepare and then share it via some link that you can download later on.
Thank you.
Okay, welcome.
Okay, thank you.
Okay, welcome.
Daniel?
Yes?
On the commercial virtualization, we use Fusion Compute, is it?
Uh-huh.
And open source we use?
No, in Huawei, it's only closed source because you need to pay licensing fee to Huawei. They will give you the support and things like this. They simplify all the deployment. So if you're going for Huawei solution, it will always be closed source.
Okay.
Okay, but they develop their product using open source KVM platform. These are the differences.
Daniel. Hi, Daniel. Daniel. Where are you, Daniel?
Hello, can you hear me?
Hey,
This is Meryl.
yes, Meryl.
Maybe Daniel
Meryl.
has left for a break. So
Yeah, it's 15
Okay.
minutes break over. Why are you calling Daniel?
yeah, if you have any questions, you can ask in the group, and we will respond to you.
Okay, thank you.
Have you joined the group?
Yes.
Yes. Please ask in the group.
Okay.
Okay. Thank you for your cooperation.
Okay, so let's continue. Okay, so next thing I will be doing some installation demo to you guys. Okay, so I will be using Huawei Remote Lab to install a 2 CNA node. Okay, so this is the Fusion Compute installation demo. Okay, so this is to show you using the real equipment, how does it differ like what we see yesterday from the simulator website. Then I will also push the VRM, okay, to run on the CNA1. Okay, so this one will be created as a management cluster that you will see later. Okay, so from your configuration, it will be a IP address here, 192.168.123.101. Another one will be 192.168.123.102. And the IP here, I'm using a standalone VRM, 123. Let me see, .50. Okay, .50 for the VRM. So I'll be doing ISO install for this two. Okay, then I will do the virtual machine import. Okay, with the installer.exe. Okay, so I'll show you all this in the Huawei lab itself. Let me just open up another one. Okay, due to the class size, we do not have enough equipment for you guys to practice the lab together. So I will do the demo during this training. So you will get a video capture for this training. Later you can refer as your guide that you can practice on your own. It's either you deploy your own lab with your own hardware, or later they will help you to arrange some eLab application resources, okay, for you guys. So let me just log in to the eLab website. So remember, as you can see here, we have 2 CNA installation will be done with this IP. And then I will also do installation for the VRM. Okay, so let's look into it more in depth on the lab perspective. So I will also show you how to access the lab itself. Okay, agree. Okay, so once your Huawei account, okay, applied the eLab successfully, you will have one eLab here ready. So when you click on it, you will have a remote terminal machine for you to connect into Huawei China data center terminal server. So that from the terminal server, you can access to Huawei hardware equipment. Then from there, you can try to deploy your software. Okay, advanced, exception, confirm. So you will come to the Fusion Access login page. This is Huawei Virtual Desktop Infrastructure Solution. So if you plan to deploy Fusion Access, you will see that from an end user client, this is how we access to our remote desktop machine using web GUI interface. So here you will have a assign account to you with the password. So with the unique username account and the password, they will log you in and bring you to the machine that is assigned to you. Okay, so from the browser, they will help you to log in to the remote desktop. So you will see I am logged into the Windows Server 2012 R2. So from this remote desktop, okay, you can now connect to Huawei equipment with their own private IP segment. This is the gateway for the 123 network, and then this will be the gateway for the .18 okay, for the storage. So let's look into it more in depth. So we have two machines ready here. As you can see, one is used for CNA1 and the other one is used for CNA2. Okay. So I will install CNA1 first. So you will see here, just now I mentioned to you, Huawei do have their own operating system running on Linux. It's called the Euler OS. So the Euler OS will come with the KVM module when you deploy the CNA ISO file. So this is the CNA ISO boot menu. So I will select install, okay, to load up to the CNA ISO file on CNA1. So when I type in install, they will just load up into the Euler OS installation wizard that we see yesterday from the simulator website. So once your installation wizard put it up, you will see something similar what we actually saw from the website yesterday. So first you need to select which hard disk available for you. So by default, SDA is selected. So I will not change that for this particular machine. So I will change the network options. Okay. So I will utilize Ethernet 01, the first network interface port for my management IP. Okay. So I will go for connect now. So I will select manual address configuration without VLAN in this environment. Okay. This is a Huawei pre-designed environment using IP address 101 for the management. Then the net mask will be /24. The gateway will be 192.168.123.254. That's the gateway. No VLAN tag required. Okay, just click on tab or arrow key to move. Okay, to confirm for the network interface. Okay, then we can now move to the default gateway also using tab to put in the same gateway IP. Okay. So most of the time in a lot of installation, we will choose the first network card option. So in production environment, you need to know which particular network card is designed to be used. Okay, for your management list. So most of the time, the server might come with 1 gigabit connection and 10 gigabit connection. Management, most of the time, we will be using 1 gigabit, for example. So let's click tab to OK to accept the network configuration for now. Okay, then next thing, it will be the host name. So the host name, we will change it to CNA1 just to identify it from the console. Time zone, make sure you are in the correct time zone. For me, I am following Beijing time. I don't change the time zone here. Then the password. So the password, I'll be using my own password for the root account. So this password is required later for you to deploy your VRM machine. Okay, so confirm the password. Then when you tap to OK to confirm this result, use the hard drive configuration to install the OS, then they will actually tell you this particular original data will get erased. Confirm a few times, then the installation will actually start. So if you apply eLab resources from Huawei, you will have similar experience what I am looking into. So from here, they generally utilize one server hardware to deploy multiple instances for you. Okay, so let me just show you some extra information. Okay, so from Huawei, their KVM machine can only install using KVM platform. So we have one physical server that comes with the IP 192.168.123.1. So here is basically the CentOS, okay, CentOS. It's a CentOS deployed. Okay, it's basically a Linux plus KVM in this hardware. Okay. Then later they will create different virtual machine CNA 1 and also virtual machine CNA 2. Okay, I am doing installation here on this layer. So I will install my CNA ISO in this particular layer. So I am accessing a connect with VNC login. So initially you will see from my lab machine, okay, I am having a port 5900, port 5901. Okay, so this is the only supported Fusion Compute nested environment. Okay, they can only support KVM. So yesterday, some of you asked, do I able to install in Windows Hyper-V? That is not supported yet currently. Okay, sorry to say that. So you need to go for KVM platform. Okay, so when you get hold of the instructor material, there will be another extra lab deployment guide, okay, that you can read through. They will show you how to create these instances. So when you apply Huawei eLab solution, they already pre-configure the CentOS and KVM for you. Don't need to worry about that. Okay. So the CNA cannot be run on Microsoft Hyper-V nested environment. It cannot support VMware nested environment as of now still. Hopefully later they open up this support flexibility, then it will be easier for us to deploy. So hopefully you get some idea what I am actually working on from Huawei Equipment Lab. So I am installing multiple CNA instance running on a physical machine from Huawei with CentOS and KVM. Okay. So you are either going for CentOS or KVM, or you can also support, okay, if not mistaken, they have another flavor using Ubuntu plus KVM too. Okay, so these are the things. installation just finished. Okay. So you will see we will boot up from the UVP on the KVM platform. So after the installation has been done, they will try to reboot and load into the ULOS plus the KVM module. Okay, give it some time to load. So you need to make sure you are able to log into the OS and try to log in with the password that you've keyed in earlier into the CNA console. To make sure it is installed successfully, and later I will just type in some command to check the interface IP address, just to make sure I did not mistype anything. Okay, so you will see here, first thing, after it is booted up, they will show you the CNA host name that you put in earlier in your installation wizard. So I use CNA1 just to identify to yourself which CNA node you are now logging into. So I'll be using the root account. So the password that you set in the wizard just now is basically setting the root account password. So all this, they created a wizard base for you to do your installation. So I can log in with the password that I keyed in just now, and I will type in maybe ifconfig. Actually, we just check, okay, what is the IP address that are assigned to the interface earlier. So you will see that with this command, I can check Ethernet 0 is the one that I selected earlier. I am having the IP address with 192.168.123.101. This is the net mask. Okay. So at least I know that the interface IP is the correct one. So what I will do here before I continue to deploy the VRM, I will just try to ping, okay, because from the terminal machine, I will need to able to connect to the CNA management IP before I can continue to deploy the VRM software into it using the installer tool. So first thing, after you have logged in, check the IP and try to ping from your terminal machine, see whether you can contact this IP or not. Okay, so double check on all these things if you get the ELAB resources from Huawei. So after that, I know that I can connect to the IP address. I will now open up the tool itself. So I will minimize the command prompt and the CNA1. So I am using CNA1 now to deploy my VRM. Okay, so when I go to ISO, I already unzipped the installer file. So these are the things that you need to download from Huawei. First is the installer tool, then the vrm.zip file. This is the VRM virtual machine template. Things is. So the ISO is already loaded to the CNA host that we do not need to download it in the ELAB resources. So I will open up the installer folder, then run the Fusion Compute installer. Okay, so this Fusion Compute installer is a wizard GUI that will guide you through what you need to deploy the VRM software. So as already mentioned here, this tool can also use to deploy PXE-based installation to your CNA host server. So just uncheck the host option. Next, for the VRM. So I will just go for typical mode. Okay. I do not want to customize anything in it. Next, and I will need to select the package. So you need to know where your .zip file is stored for your VRM at least. So I actually have the VRM template image in the ISO file on the desktop. Then OK, then you click on verify. So they will check whether there is a vrm.zip package, as you can see here. So if they detect it, they will help you to decompress it. After decompress, they will check whether the file is actually valid for your next continuous deployment. So you will see here, you will start here. Before they can verify everything, you cannot click on next whatsoever. So we'll give it some time to extract the VRM file from the .zip. Okay, so after the verified extraction, I will show you from the folder what are the files actually come out from the .zip itself. So you see after decompression, they will actually see and check the component whether it is 100% there or not. Verification succeeded, then only you can click on next. So before I click on next, just let me go back to the folder. Okay, to the ISO folder. You will see that from the .zip file, it is extracted into the OVF and the VDA. Now, this is actually a virtual machine template format, okay, that is used in Huawei Fusion Compute. So you will see here, this is the OVF file referring to the virtual machine configuration, and this is the virtual disk itself. Okay, for the VRM, it's already compressed as a template image, so it will be smaller in size. So these are the files required after extraction to import into the CNA node. Okay, so minimize the ISO folder. So from the installer 2, I can now click on next to continue. Then they will bring you to the VRM installation wizard. Okay, so from this installation wizard for the VRM, you can now define parameters. Okay, when you click on next, you can put in the VRM configuration parameters. You want to go for active standby, you will require 2 physical CNA nodes, and they will deploy 2 virtual machines for the VRM and require more resources. So for a test environment, I will go for the standalone install mode for VRM. Then when you go for system scale, you can move to this question mark. They are telling you VM refers to virtual machine, PM refers to physical machine. And when you click on the drop down button, this is the minimum specification you can go. So if you are planning for lower than 50 CNA node physical machine, and then lower than 1,000 virtual machine in your environment, then you should go for this particular scale. So the system scale here will determine how much resources like vCPU and RAM memory plus hard disk space to assign to the VRM software. Okay, so in most environments, the first option is more than enough. So it's designed, if it is designed for higher enterprise level, you can increase the number here, okay, when you do deployment. So the node IP here refers to the VRM management IP. So the management IP designed by Huawei is 192. 168.123.50. Normally, the same segment range as your CNA node management IP. Subnet mask /24. Gateway will be 192.168.123.254. Okay. So this IP address, subnet mask, and gateway will push into the VRM configuration using this wizard. Okay, so this is the VRM configuration initially. Click next. Okay, so they will verify the IP address, everything, whether it's correct or not. Then they will ask you to select which host to push this VRM virtual machine. So I just installed CNA1 earlier. I'm using CNA1 to host my VRM virtual machine. So I need to put in my CNA node IP address, CNA number 1, then the root password that you set during the wizard installation. Okay, so with these two, next thing when you click on install VRM, the installer tool will help you to push the virtual machine template, okay, into the CNA host, and then further configure your VRM virtual machine with the correct management IP. Okay, so the VRM virtual machine template is basically what we call sometimes the virtual machine appliance. So in that disk, they will come with the operating system, they will come with the KVM management tool, and also the VRM web GUI application for you to log in later to manage the virtualization platform for Fusion Compute. So all this is already pre-installed as a template. We just need to push using the tool, and they will help you to change all these parameter and configuration. Okay, so this will require some time to push the VM into it, somewhere around 15 minutes maybe. Okay, so some extra notes over here while waiting for the installation. Okay. Now, if you actually deploy, for example, like my case here, I am using Fusion Compute 6.3.1. Now, if you go for 6.3.1, your CNA.ISO will have 6.3.1 version. Your installer too will have its own version set, and also your vrm.c. You will need to look for 6.3.1. It's a package. So if you go for 6.5, okay, so you will have your CNA, ISO, installer 2, and the VRM all running in 6.5. Okay. Then we have now the latest version available. Okay. So latest version available is 6.5.1. Okay. Now, all these versions come with its own CNA ISO, installer.exe, and also vrm.c. You need to know which version that you have downloaded, okay, which version you're using. You cannot utilize a different version installer tool and then push a different version VRM virtual machine into the CNA node. Okay? So all this versioning need to be consistent for all these three components for the deployment over here. Okay, so if you plan to install into your own environment, make sure which version you have downloaded. You need to download all these two with the same versioning before you deploy your solution. Now, if not, later you install 6.3.1 CNA and you try to push 6.5 VRM into the CNA node, this particular wizard will give you an error telling you that the CNA version are mismatched. So you cannot utilize a different VRM version into this CNA node itself. You need to look for the correct VRM version in order to solve this issue. Okay, so you will see that over here, the operation, they are now changing the CNA host to add in the local disk as a data store so that they can put in the VRM virtual machine to run on that CNA local disk. So the VRM will always be running on the CNA local disk instead. Okay. So your CNA1 now, okay, come with a local disk data store. Okay. So your VRM will be running, again, will be storing in the local data store. Okay. So the VRM is mainly runs on the CNA node 1. So they are doing all this operation backend basically using the wizard. So you do not need to do all this manually. With a wizard, it will be easier for you to deploy your solution. So you see they prepare the CNA host ready, and now they are creating the virtual machine. This VM is referring to the VRM virtual machine. So they are using the template that is extracted from your folder, and now proceed to import into the CNA node.
Why is taking so long? Is it normal?
Okay, so after the VM imported successfully, now they will power up the virtual machine. So the last part, they will help you to configure the VRM VM using this wizard. So the deployment installation is pretty easy, just that you need to have more wait time during your lab. Okay, so the ISO file and all this installer, you need to download it manually from the FTP site provided by Huawei. They will have a shortcut created on desktop normally. So when you double click on the FTP link, you need to get the FTP account from Huawei eLab resources. So this is where you can download your file itself. First thing, it will be set up on the cloud. Then you go for Fusion Compute and then look for the version that is actually used in this lab. Mine is 6.3.1. So I have all the file ready here, pre-downloaded. I just need to copy it to my desktop machine, okay, in order to utilize it. So this is one thing for the CNA and VRM installation. So if I go back to the FTP again, we have the tool folder here, ISO, Windows. You can also copy the Windows 7 English version ISO or Windows 10 English version ISO to your local desktop folder to prepare for the virtual machine installation later for the lab itself. Okay, so these are some tips for you to get ready the platform before you deploy the Huawei solution. So once you get hold of the Huawei eLab resources, if you have this video, you can always play back and see how we actually install the equipment. Now, Huawei also provide you a lab guide from the training material package. You can also refer from the lab guide documentation. It will also tell you what you need to do for all these things. Okay, so you will see that the Fusion Compute installation is now done successfully. So when you click on next, they will show you your VRM login username and password is similar to your web simulator 2. And this will be the IP address that you set earlier for the remote management. So I will open up the Firefox. Okay. So you need to access this web GUI through a browser. So I will put in 192.168.123.50 to connect to the VRM. So first they ask you the certificate issue. Just click on Advanced. Scroll down, look for Add Exception. Confirm the security exception. Okay, so you will be prompted with the license agreement here. Now, a lot of the Huawei software by default it is in Chinese, so do not worry about it. So when you see this page, scroll down, check on I agree. It's by default checked already. So I agree to the license agreement and then click OK here. After that, you will see that your interface is still in Chinese. Just look for an English button in the top right corner. Okay. So click on the English button on the top right corner. Then they will convert it into an English interface. So remember to do that before login. If not, the entire interface will be in Chinese later. And inside the Fusion Compute web GUI, there is no options for you to change your language. You need to log out, change your language again, then log in back into Huawei Fusion Compute. So these are the username and password that I will type in now to change the password for the first time. AIAAS Alliance Auto dash collect 8 exclamation mark. Okay, log in. Then they'll prompt you for the initial password change. So you need to do this at least one time so that you utilize the new password to log into Fusion Compute. Okay. So just need to type in the old password. Okay, new password that you want to put in. So just utilize my own password. Okay, confirm. So password already changed. And they'll bring you into the Huawei Fusion Compute VRM. So after you have done this, this particular wizard can click on finish to complete the installation. Okay. So you will see here from the web interface, this is initially where you will do all your labs with the VRM web UI. So when you click on the system tab, okay, so from the simulator 2, they will actually bring you to the system configuration where you can add in your license key if you have any. Okay, so for us, we will be using Foundation. 6 sockets only, as you can see here. Okay, 1 CPU, 6 sockets in total, for example. So if you have anything more than that, you cannot utilize the trial license anymore. And you see that your trial license by default has unlimited time frame. Okay, so for testing purposes, you can always utilize this straight away. Then your time management, you can configure an entity server that we see before, okay, in the simulator 2. So next thing, when we go to the resource pool, okay, the management cluster is already created. So I already have one default cluster to be used. Okay, later in the training, we will also discuss about what are the extra features provided in the cluster. So I will wait for that later. Then you will see that CNA1 is added into the management cluster. So the CNA1 after installation, you will see that this is the IP and total CPU resources. That is 28 gigahertz plus 20 gigabytes of RAM memory. Okay. So you will see that your particular overheads will be used up to like 8 gigahertz plus 5 gigabyte. This is mainly used by the Euler OS and the KVM module. Okay. So when you actually see more here, on the right, you have all this information regarding CPU usage and also memory usage. So the reserve here is mainly for your Linux operating system and the KVM module running behind. Okay, so you have the CNA1 ready with this VRM ready. Next thing, we will need to deploy CNA2 node. Okay, so let me just minimize the VRM software. Okay, I will now go to the CNA2 node, as you can see here. So CNA is using port 5901. Okay, it's all accessible from this VNC viewer. Okay, so you need to know which particular server IP that is hosting the CNA node. Then they will come with different port number for you to access the console. So just double click on it, you will open up this particular console. And you can continue to do your CNA installation. So you need to prepare all this, especially when you're preparing for your lab exam. So you need to do something similar on this. So with the video, with the lab guide, and later you can deploy your own hardware or apply maybe Huawei eLab resources for you to practice your lab. Okay, similar things. So load up to the installation wizard. So I need to put in the network here for Ethernet 0. So for CNA2, the IP will be 192.168.123.102. Subnet mask /24. Then the gateway IP. Okay, 123.254. Okay. Then you can move to the default gateway IP 192.168.123.254 again. Okay, to accept the network configuration. Next thing will be the host name. The host name here I will put in CNA2. Okay, time zone I will leave as default, Beijing time, then the password here. Okay, so the password is actually for root account password. Okay, then just tap to the OK button, accept it a few times to confirm the installation. They will wipe the entire disk and start to install the operating system and the KVM module. Okay, pretty similar like the CNA1 installation. So after the installation, I will go back to the VRM and add in the CNA2 into the virtual cluster. Okay, so you see that the CNA2 is fully installed, and now put it up to the console. Same thing, I will try to log in with the root account and the password that I assigned earlier. So root account password ready, can be used. Next thing, I will check the interface IP address. So the interface is using Ethernet 0 with the IP address 192.168.123.102 from the mask. So this is the correct IP. So I will try to ping from my terminal machine just to make sure the network interface work on this CNA node 102. Okay, can be pingable. Okay, so next thing, let's minimize the console. I will go back to the VRM web interface. Okay, so from the VRM web interface, select management cluster. Okay. Need to log in again because it's already timeout. Okay, so go back to the resource pool. Select management cluster. Okay, so under management cluster, you have the option called the add host button. Click on add host. Then I can add in my CNA2 into this VRM as the manage CNA host 102. Okay, next, confirm. So the process will be ongoing. How to check your task? You can go to system button, then select the task and logs. Then you will see the task center here, trying to add your host. Okay, so it will take some time. Okay, is succeeded. So when you see this message, CNA2 is added into the VRM without any issue. Just to double check, when you go to resource pool, you see that under the management cluster now, total resources now pump up to 60 gigabytes, and you have 28 gigabytes of RAM memory. Okay, so you will see here for your CNA 1 and 2, they come with the same specification. Okay, but in total, you have more resources because the CNA 1 is running the VRM01 machine. So for the VRM, as you can see here, okay, on this VRM hardware, how much resources do they actually configure to it? CPU, we have 4 cores to the VRM VM. RAM memory, they put in 5 gigabytes for it. Okay, and also 120 gigabytes of disk space. So you need to make sure your server host at least has resources more than this giga, so that you can create extra virtual machine in the same CNA node if you have only one single CNA. So for this environment, they have 2 CNA nodes. Each of them come with 20 gigabytes of RAM memory. It should be sufficient for your subsequent lab to create virtual machine. Okay, so you will see here from the CNA node, now it is still empty without any storage resources. So tomorrow when we cover the storage and the network portion, you will have a better idea what does all this looking for, and also the network resources that we are going through. Okay, so this is how you can actually deploy your CNA and VRM solution. Okay, so when you go to the system under right management, you can always manage your user account over here, as you can see. Okay, so I can add in extra user account here so that to facilitate multi-access login. Okay. You can even change your password policy to a less complex format for your password. Okay, and things like this. So these are the extra options that you can actually check and configure. Okay, so that's about it until today. Okay, I will keep it for tomorrow. It's quite lengthy for today already to understand the virtualization layer and also the installation for this CNA and VRM. So I hope you actually get more idea what you need to do for the first part of the lab to make this platform ready. So some of you started to install, download the ISO file and all these things to prepare your own environment. So you can try that. If you have any question, do post into the group. Okay. So there are still time over here. You can actually post questions to the group whatsoever. We will try to answer you. Okay. For the content part, we already done for the day.
Hello, Daniel.
Yes.
Yeah, okay. I observed that the operating system used here is a Windows 2012 server R2.
It's a remote desktop
So,
here, right?
yeah. The remote
Okay.
yeah. So can we use any other version of operating system? Maybe Windows 10?
No. This is just a terminal machine for you to connect to your CNA for installation. It doesn't matter what version you use for this machine. This is the machine deployed by Huawei for you to remote connect only. It doesn't matter.
Okay. I don't need to bother myself with this.
Yes.
Okay. Let's start. Yeah, the three files yesterday, I forgot the third one. I know I must download the installer.
So you will have the, let me just
and the ISO, and which one?
Okay, so if you are looking into the file, right, for Fusion Compute, okay, you need to, so you need to download the CNA ISO,
Yes,
then the installer.zip, and the vrm.zip.
The vrm.zip is about 2.5 gig. Now, I have challenges in downloading this file. It will get to 60, 70%. The website will say it's hanging out. My session is expired. Then it has wasted a lot of data here. So what do we do?
Yep, I know you posted the question in the group, right? So we will be waiting for Huawei personnel to help you to check on that. Maybe due to your internet speed problem, or maybe their website is having some issue sometimes. So they will actually reflect to you. This one I cannot really help you from my side. Okay. But I just let you know what are the file you need to download. 2.5 gig, yes, for the VRM is quite huge. So you need to see whether they will provide you another download link or not, things like this. Okay, because all these resources is coming from China, most probably.
Okay. Yeah, the Ocean Store here, what are you using it for?
Ocean Store?
Ocean
This
Store.
is the
This
BC
Ocean
Manager.
Store
This one you don't need to download because it's the e-backup software mainly used for virtual machine backup. It's not covered in our training. So this one will be covered in HCIA training later. Okay.
All right.
Okay, thank you.